Hello again, everybody. So today I'm going to do a run through of the second part of this R tutorial. So we're going to go to tutorial part 2, read through this chapter, but I'm going to skip over that because I'll let you do that on your own. There's also linked reading in here. Graphical analysis, workflow basics, and data transformation that you should read as well, along with working through this section of the tutorial. Download the GitHub repo. And then I'm gonna open that, bring that into our folder for the class, and then remember we're gonna open it up from the project. Once we have that opened, we are then going to open up this blank Unit 2 blank markdown. You're not going to be handing these in, but it's just good practice to get in the habit of starting your workflow with saving your own copy of this. So you have your copy, and then you also have that blank copy if you ever need to go back to it. So here are the learning objectives. Obviously, you can use this as a calculator. 8 times 9. And then the assignment operator. We can say the answer is 8 times 9. And then all we do is we would just call the answer, and it would tell us what that is. The other thing is that this is a code chunk right here. So to insert code chunks, you just go up here and do that. This right here, this is actual code, and if we put that in front of it, that's called commenting it. And so then that just becomes text. So if you want to have text in there, you comment it. If you want it to be code, you uncomment it. So that's that. And then to remove something from your environment, you just do that. Combine. So if I just want my name, do that. If I want multiple names, I have to do this C, which is combine. And similarly, if you want multiple numbers, you would just do that combine. Yep, so then you could do this. You could add 5.4 to the water pH. Then you could then remove that, like I've already shown you. So you can do things like this where you know it's going to be incorrect, and then use that as a way to interpret the error messages that are good too. So play around with that a bit. This section is telling you about how to interpret information from the internet. So stuff on the internet that's guiding you will often just use shorthand. So it'll be like DF, that just stands for data frame. So DF, your data, etc., etc. Okay. This function section, you can go out to here, and I'll let you work through that. So as a reminder, you're working through the blank, but all of this stuff is on this web page. And so you can run through using the sequence function. So this is the full syntax. So from 1 to 10 by 1 will give you this. You can also get rid of the from, to, by. Using the full syntax is nice, like when you're showing somebody for the first time. But then once they know that this is the default sequence or the default like order that stuff goes in, you can get rid of the from, to, by. So that's what's happening here. These are equivalent. This is just more, verbose, if you will. You can also get rid of the by one because that's kind of that's the default, and so R will just assume that. And then before you scroll down, just predict what this 10 and 1 is going to do, and that should probably be pretty obvious for you. Next thing, we're going to read in some data, so we are going to read in the flow data. So we'll go down. We're going to load this library. You're going to have to, after you install it, you don't have to install it every time, but you do need to load it when you come back. Now we put in flow, RBI, a tibble. You should read about what a tibble is. You can do head and structure, and it'll give you some information. Remember, read underscore CSV will bring it as a tibble. Read dot CSV will not. So you can play around with bringing in the data frame using read dot and see how these, the flow, not a tibble, and the flow, see how they're different. And then remove it. All right. So I'm going to run through a little bit of deploy, filter, arrange, select, mutate, and summarize. Summarize is also reframe. Is kind of a newer version of summarize that you can use them either one. I tend to use summarize. Okay, so write an expression that returns data in RBI for the state of Montana. So before you look at the answer, I would encourage you to give that a shot and see how it goes. So pause this, give it a shot. Maybe not look at the right answer on our book down page, and then come back. And I can show you how I'll do it. So this is how I would do it. I would start a new data frame called RBIMT. It's coming from the RBI data frame. I'm going to pipe. So remember, pipe means take. So what this is saying is we're gonna assign. We're gonna make a new data frame called RBIMT. We're gonna start with our RBI data frame, and then we're gonna do the stuff that comes after this pipe. So what we're gonna do is we're gonna filter state is equal to Montana. And so then if you look in here, it's just going to be data for catchments in Montana. Similarly, give this a shot from the flows data frame, make a new data frame that has only flows less than 100. So I'll let you pause and give that a shot, and I'll show you how I'll do it. So it's going to be a very similar looking script to what we just wrote. CFS, so we're going to look at the CFS column, CFS less than 100. So now this just has flows less than 100. max. So we can check that that works by saying, give us the max of the load flows in the CFS column. So that $sign CFS means look in this data frame in this column. And that's the max value. Here I said that we didn't save it, but I actually did that. So you could do this by just doing that, and that wouldn't have saved a new data frame because I didn't do this bit with the assignment operator. Okay, so now you see that multiple conditions. So now try this one. So you already have this RBIMT. How many of them have an RBI greater than 0.05? So we could do that we could basically apply this filter to this RBI Montana, or we could do this as multiple conditions. So I'll show you how to do that. So I'll just call this RBIMT greater. So I'll give you guys a second to give this a shot. So you're going to filter on multiple conditions and then come back and I'll show you how I'll do it. So we're going to say filter. State is Montana, and RBI is greater than 0.05. So now we have that. Turns out that 15 of the 17 stations in Montana have RBI greater than 0.05. So here's a challenge for you. So filter for flow less than 100, just for the NR and North Fork dryer engaged in flow. So this should give you a hint as to how to do that. Okay, arrange so you can sort in ascending and descending order. So I'll just do one of them and then let you play around with that a little bit. So we're going to do RBI of RBI arrange. What am I doing wrong here? I never use range. What did I do wrong? There's our filter stuff. Multiple conditions. Oh. I put the arrange inside. So that would arrange it. So that way, in my example, I wrote it as a pipe. You could similarly put the RBI, tell it the data frame is right there. And just run this, and it'll do the same thing. And then you can do it descending. Select. Okay, so if you only want a couple of columns, so we want site name, which in that data frame is called station name. We want state, and we want RBI. We can do that with select. So let's just say RBI thin. This is going to be RBI where we select just the. Is that how it's written? Yep. Station name, state, RBI. So now we have that, which just has these three variables. The other thing that I will show you is that I would also, if I was going to work with this data frame for a while, I would name these in a more, in just like a way that's easier for me when I'm actually writing code. I usually stay away from uppercase. Oops. So you can do that with rename. And you'll see when we get into downloading like USGS data, see, so now these are named how I would like them. Mutate. So mutate is how we make a new column. So here you are asked to make a new column in RBI that is T-range. So I'll let you try that real quick. This is a hint. And then I'll finish this off. So T-range is going to be equal to T max site minus T min site. So now in there, if you go to the end, there's going to be a new column called T-range. So the thing that I did here, I said RBI equals RBI. I'm using the terminology equals literally. That's, you know, assignment operator is basically the same as equals. You could also use equals right here, and it would do the same thing. But by convention, we use the assignment operator there for when we're making objects, and we use the equals in any kind of calculation. So we save the equals for math that you're doing. Yeah, so we'll get into downloading some USGS data. And the site number column has to come in as a character, so you can practice this. Summarize. So this is where I was saying this could also be reframe. Let's do, okay, so we're just going to do RBI sum is RBI, and you could do this as summarize or reframe. Either will work. Mean RBI equals the mean of RBI, right? I didn't change the, how that's written. Yeah, it's still uppercase. Mean of the RBI. Min RBI equals the min of RBI, and so forth. So you could, you know, put the max in there. You could also change this to summarize. So play with that a little bit. And then we could do it as like RBI Montana, or let's do RBI state sum. So here we're just going to do what's called group by state, and then whoops. And then do summarize or reframe, whichever one you prefer. I won't go through all of the mins and maxes because it'll all be the same. And so now if you go to this, you're going to have the mean for each state. And remember, RBI is the flashiness index, the Richard Baker's flashiness index, so it tells you like how quickly the hydrograph would go up and down in response to precipitation or snowmelt. Okay, I've already been using pipes, so pipes should start looking somewhat familiar to you, but you can go through this. You can also read in the R for Data Science more about piping. Okay, so what do you ask to do here? Basically takes that to that. Take the revised and summarized code from above and perform that version. Okay, I just did that. And then lastly, if you have an NA and you try to take the mean of this, it's going to give you an NA. So say I do this. And you will have data that you download that has NAs. You know, sensors like run out of battery or whatever, so they'll be like gaps in there. So you can fix this by saying the mean of x na dot remove equals true. And it'll give you that. And so when you do summarize, it's, so like, let me go up to this. What was that? Yeah, so right in here, it's a good habit to get into just telling it this, just in case there is an NA in that data frame. It's just kind of, it just ensures that this will actually run. And the other thing that you could do is you could always go through your data frame when you bring it in, and you could do like a NA omit or something like that to get rid of any rows that say NA. So that is the end of that tutorial. If you have any questions or you want to hop on a Zoom and run through any of that, reach out to me and or the TA, and we will be happy to help you out. And yeah, hope that's helpful, and we will talk to you soon. Okay, bye.